This next section deals with proving that lines are parallel. We've already learned about some of the properties of parallel lines, and we're now interested in using those properties, such as postulates and theorems, to prove that lines are actually parallel. As a quick review, I want you to take note of some of the different symbols that are used to represent parallel and perpendicular, as well as two lines cut by a transversal. The symbol looks like this. And angles, we use for plural an angle symbol with an S inside. Our first postulate says if two lines in a plane are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. Our next theorem says that if two lines in a plane are cut by a transversal so that a pair of alternate exterior angles are congruent, then the lines are parallel. The next theorem says if two lines in a plane are cut by a transversal so that a pair of consecutive interior angles are supplementary, notice that this says supplementary, then the lines are parallel. And lastly, if two lines in a plane are cut by a transversal so that a pair of alternate interior angles are congruent, then the lines are parallel. That is 4 different ways that we can observe the properties of angles when two lines are cut by a transversal, and we can use those angle properties in order to prove that the lines are parallel. There's another postulate called the parallel postulate. The parallel postulate says if there is a line and a point not on the line, so here I have a line and another point not on the line, then there exists exactly one line that is parallel to the given line. And that's what I've indicated here by the dashed red line. In a plane, if two lines are perpendicular to the same line, then the lines are parallel. So this is a 5th way to prove that two lines are parallel. The first 4 use properties of angles, and this one uses a perpendicular line.